Matrix transpose. The transpose takes the rows of a matrix and turns them into the columns of a new matrix. Or equivalently, we can say that the transpose takes each column of a matrix and puts them into the rows of a new matrix. So the ij entry of A becomes ji entry of A transpose. Here in Julia we define A, which is a 2 by 3 matrix. Its transpose is a 3 by 2 matrix. The properties of transpose. The transpose of A transpose is A itself. If we have A times B, its transpose is B transpose times A transpose. Recall that we have a similar relationship for the inverse of matrices. Maybe this helps to remember both of these formulas. And if we have A to be m by n and B to be n by p matrix, R and S are scalars, then we have R times A plus S times B transpose is just R times A transpose plus S times B transpose. So two special matrices are symmetric matrices and skew symmetric matrices. A matrix, an n by n matrix, is symmetric if it equals its transpose. And we say A is skew symmetric if it equals the negative of its transpose. Recall that matrices that consist of all ones and zeros, with each row and each column having a single one, are called permutation matrices. So to create a permutation matrix, we grab the identity matrix and rearrange the rows. So here I have a 5 by 5 identity matrix, and we rearrange rows the way we see here. The third row becomes the first row. The second row remains as the second row. The fifth row becomes the third row. The first row becomes the fourth row, and the fourth row becomes the fifth row. Now we can easily check that P is not symmetric. So that is, P transpose is not equal P. But we can verify that P transpose times P equals P times P transpose equals the identity. This means the inverse of a permutation matrix is its transpose, which is very easy to compute. Let's verify this in Julia. We create a list of indices that we had, 3, 2, 5, 1, and 4. Then we create a 5 by 5 identity matrix here. Then we reorder the rows to get our permutation matrix. Then you can check that P times P transpose equals the identity. Next time we're going to talk about vector space Rn.